Okay, now let's start. Okay, so refraction of light. Now, previous was the reflection. Okay, so there's a difference. Now, reflection, just a bit of a recap. Reflection, we talk about light travels to a surface, it strikes the surface, and then it got reflected in a different directions. Okay, now throughout this process, light ray travels in only one medium, which is air in this case, right? Before reflection, after reflection, it is still traveling in air. So there's one medium, only one medium involved here. When we talk about refraction, we are talking about two mediums, okay? For example, when light ray travel from air and it enters a transparent glass block. Okay, now let me draw it. Let's say here we have a transparent glass where light can flow through it, okay? It can travel through, it can transmit, okay? The process of flowing through this one is, we call it the transmission of light, okay? Transmission, meaning that when light ray flows from one medium to another medium, that process is called transmission of light. Okay, now here we have the boundary. This boundary, now remember guys, boundary is a line that separates the two medium. In this case, it is the surface of the glass block. The outermost surface of the glass block, it separates air, which is above, and below it, just below this surface or the line, is the glass, right? So this, we call it a boundary. This one, boundary, or sometimes you see the word interface. Please write that down, take note, okay? Boundary or interface. It is a line that separates the two medium. Let me write this down. Line that separates the two medium. Okay, now, okay, so what happened when light travels from air to glass? Okay, let's see. Now we have an incoming light coming here. Remember, this is a ray, so we have to draw an arrow, right? Direction. Okay, it strikes this point, and we can draw our normal. Where's our normal? 90° to the surface, right? To the boundary. So this is my boundary, flat. So my normal should be vertical, 90°. And this angle it makes is, we call it what? Incident angle, right? Incident angle. So this is incident angle. Right. Now, how does the light travel in the glass block? What will change? You see, the speed of light is 3 × 10⁸ meters per second. It's very fast. If you look at this one, it's like 3 × 10⁸ is like 3 followed by 8 zeros. And then meter per second, meaning that in 1 second, it travels this 3, how much is this? Like 0.3 billion meter in 1 second, just 1 second. That is the speed of the light. Okay, and it's the fastest. Okay, now fastest in the known universe. All right, so 3 × 10⁸ is the speed of light in air. Okay, now when light enters glass or other medium, the speed will change depending on the density, what we call the optical density of the object. Optical density. It is a new term, right? Optical density, what does density means again? Density is like how much mass in 1 unit volume, right? If you take a piece of it, like you take a piece of the glass material and you see how much mass is this. How much mass does this weigh? Okay, and then you compare to air. You take the same piece, same amount of volume, okay, like 1 cm, 1 cm. This is 1 cm, 1 cm. And then you compare which one heavier. Of course, the glass will be heavier. And then we would say that the glass is denser. Okay? Or we can say the optical density is higher. Why we say optical? Because now we are dealing with light. Okay? We are dealing with light, so we put this optical. Optical means light. Okay? Optics, like glasses, eyes, okay, all that. Everything has to do with the light. Okay. Now, optical density. So which optical density is higher? The glass is higher. Okay. If we have water, like air, water, and glass, which one is the densest, like the highest optical density? The glass, okay, the air is always the last. Okay, it's the least dense. Okay, followed by water and then followed by glass. Okay, the glass is the densest. Okay, densest, and then water, and then last is air. Okay, now, so when light travel, now this is very, very important. Please remember this. When light travel from less dense to denser medium, just like from air to glass, then what happened to the speed? The speed will be reduced. Okay, it will slow down. It will slow down, and then what happened? As it slows down, it's not going to take the same path. Okay, as it slows down, it's going to change path. This path is the original path. If I extend it in a dotted line, right? If I extend it like this is the original path, right? So as it slows down, it's going to move towards the normal. Again, move, I write this down here, move towards normal. Okay, so this ray, by right, it should go here, right? It should go here. But now, because the speed has reduced, so it will move closer to the normal here. It will bend. Okay, in other words, it will bend towards the normal. So how do I draw it? If it bends towards the normal, and it should be in this direction, okay? Anywhere between this line and this line. So I'll just draw it like this. As long as it is below this original path. If you draw it the other side, like on the other side, this is wrong. Because this, we would regard it as moving away from the normal. We take the original path as the reference, as the indicator, okay, of whether it moved towards or away. So if it's on this side, then it is towards the normal. Okay, you can see the light ray is bent a little towards to the normal. This is your normal line, right? Okay, then don't forget again, direction, right? Arrow. Okay, now, so this is the light ray, the direction of the light ray. What is the angle that it makes with the normal? This angle here. Okay, the angle between the red line and the blue line, the normal. What we call this angle? We call this the angle of refraction. Okay, be careful, it's not reflection, it's refraction. Okay, in the case of reflection, then we will call it angle of reflection, right? But since this is a refraction phenomena, then we will say angle of refraction. Okay, so it bend towards this. Okay, so all this happened when air travel from less dense medium to denser medium. This is what will happen. There will be a bending of light, and the speed will be reduced. Now, what if the other way around? What if the light ray travel from glass and to water? Sorry, from glass and then to air. Okay, let's flip this around. Let me get some space here. Okay, so we have our glass, and then let's assume that initially the light ray comes from within the glass. Okay, so let me draw my light ray in this direction. Okay, it's trying to exit. Now, this is the point that it strikes. Again, we draw our normal. 90 degrees to the boundary. This is glass, right? Medium 1, and then air is medium number 2. Okay, angle of incident. Angle of incident is this, I. Draw the original path. Okay, original path is this one. Just extend the line. We draw it dotted, okay, dotted. Now, when the light ray travels from glass to air, so it means that it travels from denser medium to less dense. What happened to the light ray? Okay, denser. Also, this one, you take this down. Denser to less dense. For example, like glass to air. Then the speed will increase. Okay, so light ray, as it exits the glass block, it will increase in speed. Okay, it will increase in speed, and then as the speed increases, what happens to the light ray? It bends again. It bends, now is away from the normal. So it should be on the other side of this actual path, right? Okay, this is the path that it should have taken. Okay, but because of the bending, then it will take this path away from the normal. Okay, so it's like it's moving away from the normal. Okay, so the angle of refraction, be careful, huh? It's not the angle here, it's all the way to the normal here. R is the refraction angle. Okay, so now this is incident ray, this is refracted ray. Same things happen to if the light ray travels from a water, okay, to air. Like assuming that this is, let's say this line, and this is the boundary of the water surface. Okay, so it separates two medium, air and water. If a light ray comes from the water and tries to exit, then also it will bend. So you draw the normal here, the actual path, and then it will bend in away from the normal like this. Okay, so all light ray that comes from the water to air, it will bend away normals. Same as this one, because water is a denser medium and air is a less dense medium. So the thing that you need to know, you need to memorize, or you need to remember is this one. Let me box this down here. This is very, very important. Okay, so speed increase and it moves away from normal. Okay, if you want to take this down, you can take a screenshot. I want to go to the next page. Okay. Okay, suppose that we have same glass block A. Okay, now when light ray travel from air to glass, it will bend, right? It will bend towards or away the normal. This is air is less dense, glass is denser, right? So less dense to denser, it will bend towards the normal. Okay, so we draw the actual path just for our guiding line, and then this one should be slightly below it. Okay, this, and this is our I, this is our R. Okay, now there's one physical quantity, we call it the refractive index. Oops, refractive index. It has a symbol of N. Okay, this is a new term. Refractive index, it is a measure or an indication that the ability of a medium to bend the light. Meaning that to what extent it can bend the light. That is the refractive index of a medium. Okay, for example, if I say the refractive index of glass, meaning that it is a measurement, okay, or an indication of the ability of the glass to bend the light. The higher the refractive index, the higher the bending. Okay, so here I write high N, high bending. So in this case, if the glass has high refractive index, then the light ray, the refracted light ray, will be more towards the normal. It will lean more towards the normal. The higher it is, the higher it will be leaning more towards the normal down here. Okay, so how do we calculate this refractive index? This refractive index has a formula. We'll follow a formula. N would be equals to sine I over sine R. Now this looks like a complex formula, but it actually is not that complex. Okay, it's very easy. You see, yeah, I is the incident angle, right? And R is the refracted angle. All we need to do is to take the sine of the incident divided by the sine of refracted. Then we get the refractive index of glass. Okay, now be careful. When we use this formula, there is a condition. The condition to use this formula is that the light must come from A, meaning that the first medium must be A. Okay, now just like this example here, the first medium, so this is the incident ray. The first medium is A and it enters glass. So we can use this formula to calculate the refractive index. Yeah, now let me put in some values here. Let's say this is 30. Okay, let's say this is 48 and this is 33. Given the angle I and R, calculate the refractive index. Refractive index of glass. Then we would use N equals to sine I over sine R. First, make sure the light ray comes from the A, okay? So in this case, it is. And then we put in the values. Okay, N equals to sine 48 divided by sine 33. Okay, then you use your calculator, calculate sine. Okay, sine, look for SIN from your calculator. Sine 48. Remember to put a bracket when you type it. Put a bracket, sine 48, divide, and then put a bracket, and then sine 33. Otherwise, the operation will mixed up. Okay, so sine 48 divided by sine 33.
It's 1.36447220.
Okay, normally we take 2 decimal places, so we will say 1.36. Okay, so this is the refractive index of what medium? Of glass. Okay, the refractive index of air is always 1. So every time when we calculate, right, we are calculating the other medium, not air. Okay, if air and water, then we are calculating the refractive index of water. If air and glass, then we are calculating the refractive index of glass. Because air is already 1, it's always 1. Okay, so n equals to 1.36 is your answer. And this is a measurement. It has no unit, no unit, just 1.36. It's just an indication of the ability of it to bend the light. The higher is this one, the higher the bending. For example, if you look at diamond, right? Diamond has a refractive index N of 2.4. That is very, very high. It's like 2.4. If you compare all the lights that enters the diamond, it will be bent like very, very close to the normal. Okay, the bending happens very greatly. Okay, 2.4 refractive index. Okay, you can see all the refractive index of each medium in your textbook. If you look at page 183, on top you see a table, like a small table, right? You have medium. It says water, glass, perspex, and then diamond. Okay, what is perspex? Perspex is like the material that the car plate, the vehicle car plate material. Okay, that is perspex. That is made of perspex. Okay, it looks like a glass and plastic mixed up. Okay, so that is the perspex, and then you can see the refractive index of each medium. The lowest is water, 1.33, and then glass is higher, right? So 1.53, meaning that as air enters from, as light ray enters from air to water, it bends a little bit. As it enters to glass, then it bends more. Because the refractive index is higher. Perspex even more, 1.49, and then diamond is the highest, 2.4. Okay, so now what if in some cases you're given like this? If, okay, give me 2 more minutes, then I'll let you go. Right, you see, some cases you'll be given like this. The air comes from the glass, and then it exits, bends away like this. Let's say this incident angle is 33, and the refractor angle, 48. Glass and medium. Okay, now if you're given this diagram and you're asked to find the refractive index of glass, N equals to sine I over sine R. Can we straight away put in the I and R? Which one should I put? I should be 33 or 48? Now remember again, what is our condition? Our condition is that the light must come from where? Light must come from air, right? The incident ray must be from the air, but in this case, it's not air. The incident ray is, this one is in glass. So what do? We flip this whole thing. Okay, we've changed the direction like this. We just change the direction like this, because there's a principle of light that says if the incident ray is taking this path, right, you can actually flip the path. Okay, light coming from air, it will take the same path like this. So that's why we can flip this whole thing. Okay, we just change the arrow, change the direction of the light ray. This one. So if light coming from glass to air, we can assume that light coming from air back into the glass, taking the same path. Okay, taking the same path. Right, so if we flip the direction, then which one is my I? If I flip the direction, then the 48 becomes my incident. Okay, because when I change the direction, then this ray would be my incident ray. Initially this was my refracted ray, right? Because light comes from the glass. Okay, initially this was refracted light, but after I change the direction, this becomes my incident ray, and the 48 becomes my incident angle. Okay, why do I do this? Why do I do this? I just want to make sure that light comes from air, to use this formula, to be able to use this formula. Okay, so I would put n equals to sine, so my I is 48, not 33. Okay, divided by sine 33. Then you calculate, you'll get the same answer, 1.36. And what is the medium? This is the refractive index of glass. Okay, so yeah, take a screenshot. Take a screenshot, and okay, homework is textbook page 184, revision 2, all of it, all of revision 2. I'll send it in the WhatsApp. Okay, so in the next class, I will repeat this one. I will help you revise again this one. So yeah, I'll see you on Friday. So I think we can dismiss, and bye-bye.
Bye, teacher.
All right, bye guys. I'll see you on Friday. Bye.
What, teacher?
Yeah, Jordan. Yeah, we end already. Did you take the screenshot down?
Sorry, I just came back.
You just came back.
Yeah, but I already recorded everything.
Oh, okay. Yeah, that's great. Okay, so yeah, we just finished everything, and then I will repeat again in the next class. So I'll see you on Friday. Okay.
Okay.
All right.
Bye,
Bye.
teacher.
Bye.
Teacher, do I need to repost again? The one that I just had, the question 3 one, the question 3.
No need. No need. No need.
Oh, okay.
Yeah.
So the answer will be sent in the WhatsApp, is it?
The answer. Yeah, the answer will be sent in WhatsApp.
Okay. Bye, teacher.
Bye bye.